Okay, we'll get started with the last session of the day. I'll try and keep it reasonably short so that people can get on and hit the bar or travel home, whatever you're going to do. So I'm Andrew Morgan. I'm part of the MySQL team at Oracle, and my focus there is on anything to do with high availability. So MySQL replication, MySQL Fabric, and MySQL cluster, which is one of the technologies we're going to look at today. Okay, so the topic of my talk is SQL and NoSQL. Is it possible to get the best of both worlds? So people typically think, I need to decide that I'm going to use a particular NoSQL store or I'm going to use SQL. I'm going to try and demonstrate that you can actually literally get the best of both worlds, get the attributes of NoSQL stores that people like without giving up on a relational SQL database. So this is going to be, this isn't going to be new information to most people, but to remind people of a couple of pieces of terminology for different kinds of NoSQL data stores that are out there. The first type and the simplest type is the key value store. And the key value store is exactly what it says. It's things like memcached. So I've got a key, which may be an integer, and I want to store some data against it, and that value may be a string. So it's just you've got a key, you store a value against it, you retrieve the value using that same key. Similar but a bit more sophisticated is the document store. And it's very similar in that I've got a key and I want to store this data against it. But in this case, the data can be richer. So typically it would be a JSON document. So similar to XML, if you compare it to a relational database, you have things called collections, which are like tables. But what's different is that every row in that table could have a different schema when you're using a document store. And so it's very simple to use and set up because you don't have to define the schema. But obviously it can also be a bit chaotic as well because you don't have a schema telling you and enforcing what goes into the tables. And then graph databases, not going to delve into this much at all today. This is something more specialized where you store data at the nodes and on the relationships between the nodes. So that's a bit of a more special case, so we'll skip over that. So on the left-hand side here, we can see what are some of the attributes that people like about NoSQL data stores. So simple access patterns. So applications that are very often just, I've got this data and I want to store it and I want to retrieve the data. So nothing like joins, foreign keys, etc. People using NoSQL stores, they usually accept that they have to compromise on data consistency in order to get the best possible performance. And so you'll hear terms like eventual consistency. So basically, once when you write the data, someone else reads the data, they may see something different to what you wrote. And some applications that's okay, some it's not. Ad hoc data format, you don't have to define a schema ahead of time. And they tend to be very simple to operate. So to get up and running is very quick. You don't have to set millions of configuration parameters, etc. Conversely, what's still good about relational databases? Obviously, you can have much more rich queries. So you can have joins across scores of tables. You can have foreign keys. You've got the safety of ACID transactions, so your data's safe. You're going to read back what you've written. Has well-defined schemas, so you don't have the chaos of a document store where the application could store completely random data in each row. And because they've been around a lot longer, you tend to have a much richer set of tools. So as we go through this, I've got a scorecard, and I'm going to try and convince you that with MySQL, and in particular MySQL cluster, you can get all of those advantages of the NoSQL store while still having the benefits of a relational SQL database. Okay, so just a slight diversion before we get into the technology, just pointing out one of the issues that people very often hit when they think that a NoSQL store is the right answer for them. But then this is going to show a couple of problems that people tend to hit. So I've borrowed this from Sarah May. So I heard her do this a presentation where she presented on a lot of this. So she's one of the committers for the Diaspora social networking software. And for that project, basically, they were going with a document store. And this is the process they went through and then eventually reverted back and decided they had to go with the relational store instead. So this is a simplified view of a timeline where you have a user. A user has many friends. Those friends have many posts. The posts have comments, etc. And so relational model, we all know how to implement this. We'll create some tables. We'll have some foreign keys between those tables. And it fits in very nicely. But when people look at that, they think, yeah, but if I just want to render the timeline, I'm having to do all of these trips to the database. I'm having to do all of these joins. And so it's inefficient. I'm having to read the data sort of from lots of different places, read lots of different rows. It's a pain. Wouldn't it be better if I could just store the whole thing as a single data entity and read it all in one go? And so that's why they went with the document store, because they could model all of that as a single JSON document. And so it was very efficient to read out the timeline, because single read, you've got the entire timeline. So it seemed like a good idea, and seemed to fit into the document model well, where sort of each document can have different pieces of data in it. Each document is self-contained. You just fetch the entire document. It's got everything you need inside that document. But of course, it's a bit more complicated than that, that all of these entities that are shaded in red, they're actually people. And those people are themselves users. Those users have their own sets of friends. They have their own timelines, etc. You may have other data that you store against them, say the URL of their home page. You may have their photo. So if you follow this through with the document model, you should be storing that data against every one of these red boxes. So basically, you have the same data that's duplicated many, many times over your document model. And yeah, so that's showing the JSON, that each of those, what you'd really have to do if you're going to do it in a proper document way, Fred, you'd actually expand it, and as well as including his name, you'll include his URL, his photo, all of his posts, etc. So then you end up having a lot of duplication of data and sort of a huge amount of storage. And bear in mind that some of the biggest document stores, to get any kind of performance out of them, you have to have your entire working data set in memory. Then obviously when you're duplicating that data over and over, that becomes very expensive. But of course, you don't implement it like that. And so what people end up doing is, rather than storing the users within the document, they'll store a key that gets them to the user. And remembering here that this is effectively the application implementing their own foreign keys and joins. But they've got no foreign keys or joins from the database to help them. They've got no transactions to help them. So it gets quite messy. And then the final thing, just to make it even a bit more ugly, in a document store, if we go back to how it looks here, in a document store, you're actually consuming memory for each of these effectively column names. So for every attribute, every time you store it, you're storing the string commenter as well as the actual ID of the person making the comment. And so that's, again, very inefficient of memory. So what people end up doing is they'll actually go for, instead of having meaningful attribute names, they'll just go for very short ones. And then suddenly you're looking at this and thinking, do I really have that simple data model, simple access pattern that I was after? And so that's why that project then went and ripped all of the document store out and put relational database back in. Okay, so Mysql cluster. So this is the database that at present probably best meets the attributes that people want from NoSQL stores. So it's real-time, by default, all of the data is stored in memory. It's very scalable for both reads and writes. Extremely high availability, so 5 nines availability, less than 5 minutes of outage a year. And that includes maintenance operations, so for example, software upgrades, replacing hardware, etc., changing the schema. You've got different ways of getting at the data. You've got both SQL and non-SQL APIs. And like the rest of MySQL, it's open source and can run on commodity hardware. So no need for shared storage or anything like that. The architecture is quite different from MySQL within ODB, for example. So with MySQL cluster, you have MySQL servers, but they're only there to give you the SQL interface. The data is actually stored down in these, what we call data nodes. And so no matter how you're accessing the data, you always go to the same place and you see the same copy of the data within the data nodes. When you write a row, it's written to both of the data nodes in a pair. So if you lose one of these data nodes, it's not a problem because the data's been synchronously written to a second data node. And so what that means is, and so scalability. You need more storage, add more data nodes. You need more throughput, add more MySQL servers. So it's a very simple and online scaling out story for cluster. And all of the partitioning of the data is completely transparent to the application. It doesn't have to do anything. And then in terms of high availability, every one of those processes that's now shaded in red could fail simultaneously, and you've still got access to all of the data in your cluster. So all of those processes fail, you can still read and write the data. You just need one surviving data node from each node group and one surviving API node to actually be able to get to the data. Performance. So we all know how to scale performance with MySQL. You just add lots and lots of read slaves, and you can scale out reads as much as you like. Where it gets trickier is when you want to scale writes. And so that's something that MySQL cluster's very good at. And I'm not going to go through the details of the benchmark, but this is a benchmark that was done a couple of releases ago, and sort of scaling out on commodity hardware, and with 30 servers, so 30 data nodes, we're able to scale to 1.2 billion updates per minute. And so if anyone ever tells you that they have to go with the NoSQL data store because that's the only way they can get the right performance they need, then just ask them, what are you doing that you've got to do more than 1 billion updates a minute? 1 billion is obviously a large number. Tooling, I'm not going to go, don't have time to go into the details of all the tools that are available, but we have, for example, a nice auto installer. So it's a browser-based installer. You just tell it which machines you want the cluster to run on, and the installer will go and query each of the machines, find out what resources there are, and then it'll come up with a nice configuration, and then automatically deploy the database across your servers. And then all of the regular MySQL tools like Workbench, for example, sort of those work with cluster as well. So you've got a rich set of tools. So at this point, I think we're scoring pretty well against what you need from NoSQL databases: scalable, highly performant, highly available, fairly easy to use. It could be simpler, but it's got a lot better, especially with the auto installer. And then the bonus of still being able to do joins, and so you can have a join that spans across all of the data nodes, so you can have a single join querying your entire data sets. You can have ACID transactions where, again, those ACID transactions, they cross over data nodes, so it doesn't matter how you partition the data, all of your transactions are safe. Oh, but there's the other attribute, being able to get to the data without using SQL. So obviously, we all love SQL. There's lots of applications where it fits really well. But there's also a lot of applications where people want a simpler way of getting to the data. Say, for example, if you've got a Java application, you'd probably like to just store the Java object rather than turning that into a set of relational tables. So we have a bunch of APIs. So getting to the data nodes, the wire protocol is written in something that we call the NDB client library. And so whenever anyone's getting data from the data nodes, it always goes through this C++ API and then goes over the wire to the data nodes. If you're using SQL, then you have a MySQL server that that uses that library, and then you have all of the regular connectors sitting on top of that. But if you're using Java, then we have something called cluster-J. If you're using JavaScript on Node, then we have an adapter you can use there as well. We also have a memcached API. So all of these different access methods, they're all getting to the exact same data. And you can mix and match. So for example, you could provision a user using SQL, and then you could query that user's data using a HTTP request, because they're all getting to the same data. An example of one of those APIs is the memcached API. And so here we're doing it in the simplest way. If you can't be bothered defining any kind of schema, you can have a key, which in this case is the town maidenhead, and a value that you store against it, which is the postal code. And then, so you just make that call to memcached, and memcached behind the scenes will write that to a MySQL cluster table, and you'll basically have one large table that contains all of the keys and all of the values. So completely schemaless if that's what you want. Or if you prefer, you can set up some metadata and effectively say that whenever I see a key that's got the prefix of town, then that's going to map onto this table, and sort of the key is going to be this column in the table, the value is going to be that column in the table. And so you can map that memcached API onto an existing schema, and so be able to have the relational schema behind the scenes, but get the really quick memcached key value store reads and writes into it. One of the nice things about when you're using these NoSQL APIs with MySQL cluster, you still have all of the safety of the relational database underneath. So for example, you still have ACID transactions. You still have foreign keys. And so this is an example where we're trying to, I can't remember if it was removing I think it was deleting a row maybe. But we've got a foreign key defined on the underlying table. So even though we're going JavaScript in Node.js and there's no SQL involved, we will still enforce the foreign key, because the foreign keys are implemented down in the data nodes and not up in the MySQL server. And so you can have the APIs that you want. You don't have to convert things into relational tables from the application's perspective, but you still have the power and the security of having the full relational database behind the scenes. Okay, and finally, just there's some extra resources here. So my blog is clusterdb.com, so there's a lot of stuff on MySQL cluster on there. We've got a forum that's dedicated to MySQL cluster, and if you want to really find out lots and lots about it, there is a brand new MySQL cluster training course that you can get from Oracle University as well. So that's everything I was going to cover. And any questions before we break up? No? Okay, thanks very much.